Today we're going to be talking about properties of logarithms. By the end of this video, you should be able to state and use the properties of logarithms, and you should be able to expand and condense logarithms. First, let's review the properties that we discussed in the previous video. We have log base a of 1 is always equal to 0 because anything to the 0 power is 1. Log base a of a is equal to 1. Log base a of a to the x is equal to x. To clarify this one, anytime the base of the logarithm and the base of an exponential match, then that is equivalent to just the exponent. The next property, a to the log base a of m equals m. And finally, log base a of x is equal to log base a of y if and only if x equals y. So these are the basic properties that have to do with simplifying and evaluating logarithms. The properties we're going to discuss today, the first one is called the product property because you have log of a product. So log base a of m times n is equivalent to log base a of m plus log base a of n. And this comes from the laws of exponents, where if you are multiplying two exponentials with the same base, you add the exponents. The next property is the quotient property. Log base a of m divided by n is equal to log base a of m minus log base a of n. Again, this comes from the properties of logarithms, where if you are dividing two exponentials with the same base, you subtract the exponents. Our final property is called the power property. Log base a of m to the p is equivalent to p times log base a of m. And again, this comes from the laws of exponents, where if you have a power to a power, you multiply the exponents. So what we are focusing on today is expanding and condensing logarithms. So if we follow these properties from left to right, so if we go from the printed expressions here to the ones that I wrote out, that is expanding. If we go the other direction, that is condensing. Right now, expanding and condensing might seem like a useless exercise, but it can be helpful when you are either trying to solve logarithmic equations or when you get into calculus and you're trying to find derivatives and integrals of logarithms. So let's look at a couple of examples. First, we want to fully expand these logarithms. So that means we are starting with these type of expressions and we want to end up with something like this. So in this first example, we have log of 5x cubed y. Since these are all multiplied together, the 5, the x cubed, and the y, we are using the product property to expand this. We can expand it to log of 5 plus log of x cubed plus log of y. Then we need to check and see if there's anything else we can do. We have an exponent here. We have log of x cubed. So we can use our product property to further expand that to be 3 log of x. So our final answer would be log of 5 plus 3 log of x plus log of y. If we look at our second example, we have log base 5 of x squared divided by 25 times x minus 1 cubed. The first thing we want to do when we are expanding here is to expand this fraction using the quotient property. So I can make this log base 5 of x squared minus log base 5 of 25 x minus 1 cubed. Now, I'm going to focus on the second logarithm here. I have 25 times x minus 1 cubed, so I can use the product property to split that up. So this would be log base 5 of 25 plus log base 5 of x minus 1 cubed. Now here's where you have to be careful. We have a negative here. So for now, I'm going to put all of this in brackets. So we know that we will ultimately have to distribute that negative sign. Now, we can deal with these exponents and use our power property to have 2 times log base 5 of x, and I'm going to go ahead and distribute this negative, minus log base 5 of 25 minus 3 log base 5 of x minus 1. The final thing that we can do is evaluate this logarithm. Log base 5 of 25, you're asking yourself, 5 to what power equals 25? So that is just 2. And that is our final answer when we have finished expanding our logarithm. Now let's look at condensing a logarithm. Here we have 1/2 log of x plus 5 log of x plus 1 plus 3. As long as the bases of the logarithms are the same, we can combine them. So first, let's deal with these coefficients and use our power property to condense them. So this would give us log of x to the 1/2 plus log of x plus 1 to the 5th plus 3. Now, since we are adding these two logarithms, we can use our product property and rewrite that as multiplication. Now, before we continue, let's take a look at this 3. Similarly to how we were able to evaluate this logarithm and just write it as 2, we can go backwards and rewrite this 3 as a common log so that we can combine it with the rest of the expression. So since we have just log with no base written, that is a common log, so we assume that the base is 10. So we need to think to ourselves, 10 cubed equals what? Well, that's 1,000. So log base 10 of 1,000 is equal to 3. Now we can combine these again using our product property. And I'm going to rewrite this x to the 1/2 as square root of x. And that's our final answer. Sometimes you might see logs written with an additional bracket here for clarification. It's not necessary, but it does help make it a little bit clearer. Lastly, I want to mention the change of base formula. The change of base formula was necessary when logarithms were evaluated using tables instead of calculators, because you weren't going to have a table for every single base possible. You had to be able to convert log base anything into either common log or natural log. It's not as necessary now, but it's still helpful in some situations. So, log base A of x is equal to log of x over log of A, which is also equal to natural log of x over natural log of A. So you can take a log with any base and rewrite it using common log or natural log. So if we do that with our last example here, log base 5 of 89, that is the same as log of 89 over log of 5, or natural log of 89 over natural log of 5. If you're using the calculator to evaluate this, you can just type log of 89 divided by log of 5, or you could type natural log of 89 divided by natural log of 5. The current model of calculator that we have does have a button for log base. If you go to Math, Log Base, it will let you type in the base. You can see that all of these are equivalent. So this is approximately equal to 2.789.